Have you ever paused to think about the invisible science that ensures your favorite snack tastes exactly the same every single time? Or maybe how that cutting-edge, healthier option you see on the supermarket shelf actually came into existence?
Yeah, it's a remarkably complex interplay. You've got chemistry, biology, engineering, all working sort of silently behind the scenes. It really shapes the food we interact with every day.
Welcome back to The Deep Dive. Today we're pulling back that curtain on the fascinating world of food scientists. Our mission really is to take you on a journey into the science behind your plate. We want to reveal the incredible precision, the constant innovation, everything that truly shapes what we eat.
And for this deep dive, we're tapping into quite a unique resource. It's an interview guide for aspiring food scientists. What's interesting is it's packed with the kinds of questions that really probe for critical thinking, deep problem solving, and the sheer scientific ingenuity that's just essential in this field.
Right. And for you, our listener, our goal is to extract the most important nuggets of knowledge from that guide, give you a powerful shortcut, really, to understanding the indispensable role food scientists play, from the farm, straight to your fork. So let's unpack this, because it's not just about recipes, is it? It's chemistry, safety, innovation, even a touch of artistry.
Exactly. And what's truly illuminating from these interview questions is how they reveal the core competencies and the ethical considerations, too, that define success in food science. It goes way beyond just technical skills. It highlights this profound need for clear communication, adaptability, and, an unwavering commitment to consumer well-being. Hashtag the guardians of quality and safety, ensuring what we eat is reliable.
Okay, so when you hear food scientist, your mind might jump straight to inventing new flavors, which, yeah, they certainly do. But arguably, their most critical role is ensuring everything we eat is safe and consistent. So let's start with a big one. What happens when something isn't quite right? How do food scientists actually handle non-compliance with quality standards in food production?
Well, the truly insightful part isn't just, following a checklist. It's understanding the immense pressure food scientists face to execute these steps perfectly, often in real time. Imagine a major snack brand, global supply chain. A single non-compliance issue could halt production, cost millions. So the real insight is how they balance that urgency with the scientific rigor needed for a permanent fix. It absolutely starts with prompt identification of the issue, immediately followed by a thorough root cause analysis, really digging into why the standard wasn't met. Then it's about implementing effective corrective actions to prevent that specific issue from ever happening again, all while communicating transparently, which is key. For instance, we've seen examples where a scientist quickly identified an inconsistency from a supplier. Instead of just halting production, they rapidly adjusted product specs to maintain safety and quality without disrupting the schedule. That takes skill.
Okay, so it sounds like this relentless pursuit of the why. What does a robust quality control program actually look like? The kind that tries to catch these issues before they even emerge.
Right. A robust QC program is like a multi-layered shield. It absolutely must include rigorous monitoring of raw materials right from the moment they arrive. Then there's close oversight of processing conditions, think temperature, time, pressure. Strict adherence to hygiene practices throughout the facility is non-negotiable. And, crucially, regular testing at various stages to prevent contamination. We see examples of scientists, streamlining sampling checklists, training teams on things like statistical process control charts, which not only reduce testing errors, but significantly cut turnaround times. It makes the whole process smoother, more proactive.
Constant vigilance, then. But beyond just preventing problems, there's that other challenge, making sure that once a product is perfect, it stays perfect, batch after batch. We as consumers, we kind of instinctively trust that our favorite biscuit or whatever will taste exactly the same every single time. So what are the precise techniques food scientists deploy to achieve that unwavering consistency?
Yeah, for brand reputation and consumer trust, consistency is completely non-negotiable. Food scientists achieve this through several techniques. Regular sensory evaluations where you have trained panels assessing taste, texture, appearance. Then there's precise lab testing using instruments to monitor key product attributes like moisture, pH, things like that. And importantly, when variations do occur, a meticulous root cause analysis, tracing issues back to maybe raw materials or specific processing steps. And increasingly, digital tracking systems are used too. They maintain clear records, allow for quicker identification of trends, and, proactive adjustments.
Okay, picture this. A multi-alarm fire drill, but happening in a kitchen, and it's all about food safety. When faced with multiple food safety issues at once, how do food scientists prioritize tasks?
It boils down to risk. Prioritization is based squarely on risk severity and the potential impact on consumer health. That's paramount. The most critical problems, those that could cause immediate harm, they have to be addressed first, no question. This demands really clear, open communication within the team to manage everything that's ongoing while tackling the highest impact issues immediately. So for instance, if contamination is suspected, immediate containment and testing take absolute precedence over, say, documentation or updating regulatory paperwork. Safety is always the undisputed top priority.
Makes sense. And once a quality issue is identified, what's the systematic approach? How do they implement those crucial corrective actions?
It's a very systematic approach, as you say. First, they gather all the relevant data to truly understand the root cause of the problem. Got to know why. Then there's crucial collaboration with the team production, quality, maybe R&D, to develop practical solutions. These solutions then lead to updates in processes, protocols, maybe even training. And finally, rigorous monitoring of the results to ensure the corrective action is truly effective and sustainable. You want to prevent it happening again. So for a contamination issue, for example, this would involve reviewing hygiene protocols, perhaps retraining staff, and then putting in continuous checks. This also ties directly into ensuring compliance with regulations. Staying current with, say, UK and EU regulations is non-negotiable. You have to integrate them into daily practices through audits, tests, and proactively updating protocols based on any findings.
So, detective work again. What happens if a whole batch of products simply isn't meeting those quality standards? How does a food scientist approach troubleshooting that?
It absolutely is detective work. They start by meticulously reviewing production records, ingredient logs, anything to spot deviations from the norm. Next, they examine the processing conditions, temperatures, times, mixing speeds, whatever is relevant, and they'll run specific tests on the product itself to pinpoint the issue. If, for instance, the texture is off time, maybe it's too crumbly or too sticky, checking mixing times or temperatures is often a critical first step. But what's often overlooked is how subtle environmental factors like humidity changes in the factory, or even a slight drift in equipment calibration can impact something as fundamental as texture. So engaging the production team is essential throughout this process. They're on the floor, they might notice minute shifts no one else would catch. This detailed investigation is what gets to the root of the problem. #tag the innovators and developers crafting the future of food.
Okay, so we've seen how food scientists are these unwavering guardians of quality, making sure everybody's safe, but their role is far from just defensive, right? Now let's flip the coin. Let's explore their role as, well, culinary pioneers, the innovators and developers who aren't just protecting what we eat, but actively shaping its future, pushing boundaries of taste, nutrition, even sustainability. What does a successful innovation project actually look like in this field?
Yeah, a successful research project really showcases leadership and the impactful application of scientific knowledge. So imagine a food scientist leading a team. Their goal is to develop a natural preservative, maybe to extend the shelf life of ready meals. They'd combine rigorous microbiological testing, making sure it's safe with sensory analysis, ensuring it doesn't ruin the taste. By effectively coordinating all the lab work, data review, maybe pilot plant trials, they deliver a solution, one that not only cuts waste, which is huge, but also improves product quality. That benefits both consumers and the business. And that whole journey, from concept to market, it's incredibly complex. It involves research, concept validation, intense collaboration with R&D, marketing, quality teams, and of course, ensuring compliance with all the regulations. Successfully launching, say, a new gluten-free snack that meets both consumer demand and all the safety standards, that's a testament to managing that entire product development cycle really smoothly.
That sounds like a huge win, absolutely. Now, when these new products are created, determining their nutritional content is vital. Consumers want to know, how do food scientists figure that out while also balancing health with taste and cost?
Yeah, this involves precise technical knowledge. It really starts with laboratory analysis, measuring macronutrients, fats, proteins, carbs, as well as vitamins and minerals. It's absolutely crucial to ensure these results meet stringent standards, like the UK regulations, cross-checking with approved, validated methods. This data then becomes critical input to guide formulation tweaks. You're constantly trying to strike that delicate balance between hitting health goals, making sure it tastes good, and keeping it cost-effective for the business and the consumer. For example, when developing a healthier biscuit, that precise nutritional analysis ensures it still tastes great or, great enough while meeting those nutritional targets.
Speaking of those irresistible flavors, there's one chemical reaction I've heard mentioned. It sounds like a real unsung hero in our kitchens. The Maillard reaction. For listeners who might not be familiar, what exactly is it and why is it so pivotal in food science?
The Maillard reaction. It's fundamental. It's basically a chemical tango between amino acids, which are parts of proteins, and certain types of sugars when heat is applied. It's responsible for producing that beautiful browning we see, and more importantly, that explosion of complex flavors and aromas we often associate with cooked food. Its significance in food science is immense. Think about roasted coffee, grilled meat, baked bread, that distinctive taste and appealing color. That's largely Maillard. Understanding this reaction helps food scientists improve texture and flavor. They can control cooking conditions, temperature, time, pH to enhance that sensory appeal, while maybe avoiding unwanted bitterness or loss of nutrients. It really is a key to developing superior food quality.
So that's why my morning toast is so much more satisfying than just plain bread. Wow. It's incredible how fundamental chemistry underpins our everyday delights. Now, bridging from that foundational science to real-world innovation, can you recall an example, maybe from the guide, where a food scientist had to think truly outside the box, come up with a creative, maybe even surprising solution to a tricky food challenge?
Absolutely. We've seen examples where, say, a food scientist faced difficulty maintaining the desired texture in a low-fat product. Fat gives a lot of mouthfeel, right? So instead of just tweaking the usual ingredients, they experimented with natural hydrocolloids, things like gums from plants or seaweed, to mimic fat's mouthfeel. That might have been a less conventional choice for their specific formulations at the time. This creative approach improved the texture significantly without sacrificing taste or adding back unhealthy fats. It led to a healthier option that customers genuinely appreciated. It really demonstrated that sometimes looking at unconventional ingredients can offer very practical, effective solutions in product development. Similarly, solving complex formulation problems, like, say, reducing sugar in a popular dessert without ruining the taste or texture. That often involves experimenting with different natural sweeteners, maybe adjusting fat content, playing with bulking agents. It requires several trials and lots of feedback from sensory teams.
Interesting. Now, many foods we eat are actually emulsions like mayonnaise or salad dressing. These are mixtures of oil and water that don't naturally blend. What role do emulsifiers play in food production to get that smooth, consistent blend?
Right, emulsifiers are fascinating. They're essentially molecular peacemakers, you could say. Think about it. Oil and water naturally repel each other. They want to separate. An emulsifier, like lecithin, which you find in egg yolk and use in mayonnaise, has parts that are attracted to water and parts that are attracted to oil. It positions itself at the interface, the boundary, between the tiny oil droplets and the surrounding water. It forms this stable barrier, effectively creating a microscopic coating that prevents the oil droplets from clumping together and separating out. So it's not just about creating that smooth texture we like, it's fundamentally about stability. That stability can dramatically extend shelf life. And this process works alongside other preservation methods like canning, freezing, and drying. Each tackles spoilage differently, doesn't it? Canning uses heat in a sealed environment to kill microbes. Freezing slows microbial growth right down with cold temperatures, and drying simply removes the moisture that bacteria need to thrive. When testing the shelf life of new products that rely on these methods, or emulsifiers, it involves things like real-time storage trials under expected conditions, sometimes accelerated aging tests at higher temperatures to predict longevity faster, microbial analysis to check for spoilage organisms, and, of course, sensory evaluations over time to see how taste and texture hold up. Like tracking moisture content weekly for a new snack bar to set a reliable use-by date. #tag the communicators and learners connecting science to the world.
It's amazing. But so much of this incredible science would be lost if it couldn't be communicated clearly. Let's explore how food scientists share their knowledge, not just with other scientists, but with everyone on marketing teams, managers, maybe even the public, especially non-technical stakeholders.
This is such a critical skill. It's truly about simplifying without dumbing down or losing accuracy. It means using relatable analogies, comparing a complex process to something familiar. Consciously avoiding jargon is key, and employing visuals, charts, diagrams, or even compelling stories can really help build trust and ensure that everyone, regardless of their scientific background, can grasp the key points and their implications. For instance, explaining a new complex food safety test by comparing it to familiar everyday checks, like simply ensuring ingredients are fresh before you cook, helps bridge that understanding gap pretty effectively. And when presenting research findings to a really diverse audience, maybe scientists, marketing folks, and production staff all in the same room, the key is adapting the language. Using clear visuals helps bridge those technical details to the practical impacts for each group.
That's a skill we could all use more of, frankly, especially in complex fields like science. Now, how do food scientists typically handle feedback on their communication style? Maybe from colleagues or supervisors? It can be easy to get defensive, but in science, clear communication is just everything, isn't it?
It absolutely is. And the approach described really is to actively welcome and internalize that feedback. Not just hear it, but listen. It means listening carefully, being genuinely open to adjusting one's communication style, maybe being less technical or more visual, and regularly seeking input, asking, was that clear? Or how could I explain that better next time? That helps continually refine how information is conveyed. We saw examples where scientists, adjusted their language in meetings away from being overly technical after a colleague gently pointed it out. That shows flexibility and a real commitment to improving collaboration and clarity, especially within those multidisciplinary teams. It boils down to active listening, using jargon-free language where possible, encouraging open dialogue, and having regular check-ins to make sure everyone is aligned on the goals and understands the technical side well enough.
Okay, finally, this field is constantly evolving. New ingredients, new technologies, new regulations. How do food scientists stay updated? It must feel like a never-ending journey of discovery.
It absolutely is a commitment to continuous learning. You have to stay curious. They accomplish this in several ways. Regularly reading scientific journals is fundamental titles like Food Chemistry or Journal of Food Science. Diligently following updates from professional bodies like the Institute of Food Science and Technology here in the UK is crucial for regulations and standards. Attending webinars and industry conferences is great for hearing about new technologies firsthand and networking. And crucially, experimenting with new methods and ingredients in the lab. Seeing how things work in practice is vital to see if they might improve product quality or processes. Staying curious and engaged allows them to bring fresh ideas that benefit both innovation and safety. #TAC out your site. So we've really journeyed through the intricate world of food scientists today. We've uncovered their vital roles as guardians of quality, true pioneers of innovation, and also masterful communicators. From ensuring the safety of our food supply, meticulously controlling consistency, to developing healthier products and constantly pushing the boundaries of taste and texture. Their work truly touches every bite we take.
Yeah, and what you've learned today hopefully offers a really profound appreciation for the science behind every meal. It highlights the dedication, the precision, the creativity that ensures our food is not just delicious, but also safe, reliable, and constantly evolving. You've definitely gained a shortcut to understanding an entire industry that, profoundly impacts your daily life.
So maybe next time you enjoy your favorite meal or you pick up a new product at the grocery store, just take a moment. Consider the layers of scientific expertise and careful thought that went into making it a reality.
What unseen innovation or rigorous quality control do you imagine went into making that product safe, delicious, and consistent just for you?